Intersect.
All right. Thank you. So I guess there's a few people we don't know here. So I'm Photios. This is Matt. We just want to give one or two shameless plugs before we get started. The last talk of Intersect, all your data are belong to me. Go see that. It's about iPhone stealing your whatever. But it's Matt's wife giving it, so she'd be really mad at us if we didn't say that. So she's standing right there. Sarah, wave. There you go. All right. Now she's sufficiently embarrassed. The other thing, in the interest of full disclosure, we know this is a build it track, and we are going to show some stuff from a tool that we developed. Unfortunately, we weren't able to get our code through public release and get it released in time. We would like to release something at some point. So if you came here expecting to get like the sweetest new tool ever developed, throw your shmoo now. Okay. So I guess you guys have lower standards than. Oh, all right. Considered thrown. All right. So with that, we're going to get started. So this is what we really wanted to call our talk. The gist is, everybody buys lots of expensive tools. All your data is, in those tools, and there's also cool free tools. How many of you have been in that situation where your boss is like, hey, we need a tool to do this. And you're like, great, there's this sweet open source tool that can do that. And he's like, well, who are we going to pay for that? Who are we going to pay for support? Who can we call when it breaks? And you're like, it's open source, nobody. So you go and you spend all this money on some vendor solution, and then you end up doing all the work yourself, configuring it, troubleshooting it, doing all the support, and you're still paying your ongoing maintenance and all that crap. So we want to hopefully develop a way where we can make all the expensive tools work with all the good tools. So a little disclaimer. Now, this was blatantly plagiarized from Bruce Potter. The first time I saw him speak was at DEF CON 13. He opened up with this disclaimer slide. Now, when I saw this, I said to myself, if I'm ever lucky enough or lucky enough to be able to present on stage, I hope that I can have something like this. And we don't mean that we're lying. Everything we're saying, we hope is true. But question everything. Just because we're up on stage talking doesn't mean we're any smarter than you guys. Just a little better looking. But so question the presenters. We're up here talking, and maybe you know something that we don't, but it's a fair venue for asking questions. So just a little bit about us real quick. Matt and I both graduated from RIT a couple years ago. I was an intern at MITRE, came back there full time. I recruited Matt to join our evil empire. A little bit about MITRE. We're a not-for-profit organization chartered to work in the public interest. So we're a unique organization. We work with a lot of government contractors and a lot of government agencies, a lot of other companies, and we get to be in an interesting place to help them solve some very difficult engineering problems. So there's a lab that we work in dealing with the advanced persistent threat. I'm sure you've all heard that term before. We get to look at a lot of tools, both COTS commercial off-the-shelf software and free open source stuff. They are looking at detecting advanced attacks, detecting malware, things like that. So through that lab, we were able to come up with this idea for our project because there were a lot of gaps in these tools individually, but we realized that all of them collectively could do some really good stuff. So just some assumptions that we have here. We'll get more into a lot of these later, but if you work in the defense field, you know this, right? Client-side attacks are the most prevalent attack vector. Nobody's sending remote attacks through your firewall. It's not happening. You have your rules, you subscribe to your sets, you update whatever. Those aren't working from the internet. But once they get inside, they can get out, they can exfiltrate your data, they can get out, download stuff, whatever. But we need better file examination because that's how stuff's getting in. They're sending files, whether they're through URLs and they're downloading it or through emails. People are getting files into your network and they're being used. There are good tools out there. Some vendor solutions are great, but sometimes they're difficult to use or deploy. And let's face it, real time, you're not going to get real time alerting. The moment somebody clicks on something, there's no magical analyst that's going to get some pop up. But as close to real time as you can get is very useful. So I'm going to hand over to Matt here, who's going to talk to you about the state of the industry.
Okay, so here we have a table of common products that everybody who's in defense has some of these on their network today. And these are just some pros and cons of each. And what we really like is the last line, the homegrown tools. We're trying to get more of these on our network and put them in a position where they can deliver more value and combine some of the other vendor solutions. Most COTS products today, if you work in defense, again, you know they're difficult to interface with. Everybody's got their own proprietary interface that doesn't really play well with any other vendor. There's no great top-to-bottom solution. If you go to one vendor, they'll sell you a bunch of stuff, but none of it's best of breed in each category. It's all usually expensive, and it's not agile enough to meet the adapting threats of today's networks. Also, vendors don't get rich by meeting 100% of your specific needs. They get rich by meeting most of everyone's needs. So they're not catering just to you, but it doesn't mean that all solutions are worthless. They're each good at something, and we're trying to leverage what each one is good at. So at DEF CON, Race to Zero, if you're familiar with it, is the contest to bypass antivirus engines. We know signature-based AV is very trivial to bypass. You can repack the malware. You can, as an esteemed colleague explained to us who won a couple of years ago, he was able to just make the AV engine time out without actually modifying the malware at all. He just wrapped it. And you can always unhook AV as well. And the targeted attacks, they're doing this. Current threats, again, the client-side attacks are very prevalent. And we need to do more static and behavioral analysis, but not at the level where there's an analyst in the loop. Try to get some of the triaging done as fast as we can, and then hand it off to the analyst. So there's also the common tactic where the file comes in and it's just a dropper, and then your client goes and downloads the real malicious payload. Well, that file still has to come across your border as well. So if you have things like full packet capture and that sort of thing, you can try to carve out that file and start examining that as well. And again, as from what Richard Rushing went over this morning, all they need is a very small success rate, and it's still a success for them. 1 out of the 100 emails that they send, and they're in. 0 days, we all know about this, and we're sick of talking about it. Detection is sometimes possible if you know what to look for and you're looking for suspiciousness. And again, in your industry, in your organization, you need to know how you're being targeted. So you need to start looking and amassing intelligence so that you know what looks suspicious to your organization. You can do so by using things like SSDeep and HB Gary's tool Fingerprint and building your own database of files that are coming into your organization so you can start looking for those deviations. So again, how can you expect any non-specialized tool to find things that were made specifically for you? They know your AV, they know your defenses, and they're going to come in trying to bypass all of those. They're only going to target a select number of users. The email is going to be very well crafted. Most people are going to click on that link or that attachment. So we came up with some needs that we saw that vendors weren't meeting. We need to gather intelligence, accumulate data, and we already have a lot of the files. They're coming across our border. We need to protect our network better, obviously. We need to detect these targeted attacks, and we need to be able to react faster than what current vendor solutions allow us. We also need to measure efficacy of a lot of these tools that we have. They get very expensive, and maybe a homegrown tool that we have that was cheaper is performing just as well, but we don't really know that yet, so we need to be able to line up all the tools and evaluate that. So what we are proposing is not a replacement. We're trying to tie all this stuff together. We want to augment and integrate what we already have and allow researchers to develop new capabilities quickly so we can react faster. We're just using conventional technology in unconventional ways. We had some requirements to start out with. Our solution had to have simple interfaces both on the front-end user experience and the back-end developer experience. It had to be scalable, resilient, fast, and the one we leveraged on ourselves was it had to be awesome and it had to have a catchy name. And I think we succeeded. So we're calling our solution Intersect. It's basically middleware that ties together where files are on your network and your scanning engines and your developers. It's just a framework, and we designed it to work within our organization fairly well. It ties together where the files are and all of these scanners to produce a sort of single pane of glass solution for analysts. It handles a lot of the mundane tasks and lets your researchers focus on what they're good at, finding maliciousness in files in new ways, and then consolidate all their results into one single repository so that you can perform correlation and alerting easier. We're going on the enterprise service bus model where we have producers and consumers. So in our example, producers are any service or device on your network that can see full files. So for us, that includes web proxy, the email server, that's where all the attachments are coming in, and file servers, as well as full file extraction off of a live network stream or PCAP. So they already exist on your network, you just need to leverage them. Within our solution, I put up a code example pretty quickly here to show you how easy it is to go ahead and get this up and working. On the producer side, which is probably your infrastructure IT people, they don't really need to know much about this solution. All they need to know is how to HTTP post a file to the Intersect solution. You can, this is a simple example in Ruby, or you can just use curl and upload the files. Now, in the parameters, that's where it's customizable to your organization. If you have to look at where the file's coming from. Maybe it's coming from an email server, so the destination and source email addresses or IP addresses would be of interest. You can go ahead and include that in there, and all of that is then logged on the back end for your correlation. And then we're just uploading the file. Consumers here are the services on your network that can examine the files, and you can write things from scratch to integrate with this solution by coding it right into the tool, or you can leverage everything you already have and that you already paid for just in a little bit better way. And then the results are returned to be correlated. So these are some example consumers that probably already exist on your network. We have AV scanners, the individual ones, the aggregate ones. Content detonation is getting big, and file profiling. And then there's some examples of both COTS and FOSS, free open source and custom type solution. Also, archive extraction could be a consumer where someone gets emailed a zip file. Well, you want to go ahead and blow that up and resubmit all the files. This is an example of a consumer who's connecting to get files. So again, we're taking away a lot of the mundane work from the security researchers so they can put all their time into finding maliciousness within files. So if they can implement, this again is in Ruby, if they can implement something as simple as this, bind to a queue, and we'll get into AMQP in a little bit, and grab the messages and then go ahead and grab the file, they're off and running, they're getting real data very quickly. And then all they have to do to return results is post back to a queue, and then Intersect will go ahead and consume those results and log them. I'll hand it back to Photios for the internals of the solution.
So really, Intersect is just the brains. It keeps the trains running. It gets the files from your producers, does a trivial amount of work. It just does the MD5 sum of that file, because stuff can be named differently, or you're getting it from different sources, and it determines the content type. We just simply run file, the Unix command on it, so it's not relying on the extension or anything like that. It then just takes those files and submits them to the bus. Now, the consumers will work off the bus, so they're all independent and asynchronous. And then they return their results. So we'll collect the results and we'll also correlate them. Like Matt said, it's a single pane of glass. So we'll be able to show you all the results are in one place for a specific file. So the front end, we want to keep it simple. It's a simple HTTP interface. Producers can post the files, analysts can view results from there, and your consumers can download files just like a simple Apache static file serve. So they say, I want file blah, and it gives it to them, and then they can do whatever they want to do with it. We decided to do this in Ruby on Rails. So when Matt and I came with the idea, we're like, all right, let's learn a whole new programming language, a whole new programming paradigm, and then let's take a whole bunch of technologies we've never used and throw them all in a pot and come up with a solution. So, we figured Ruby on Rails abstracts all the database stuff away from you. If you've never programmed in it, it's great. Yeah, we got a Ruby developer back there. He says yay on his whiteboard. So really, it takes all the database crap that's like 4,000 lines of Perl, and then it puts it into all the objects for you. So you just say, new object, bam, you're done. Really easy. WebRick is a standard web developer web server in there. It's supposed to be a development web server. It's been holding up to everything we've thrown at it. We haven't even had to put this thing behind Apache yet, so it's great for what we're doing. And then, final other little plug is this thing called Event Machine. It's a reactor model. So it takes all your I/O and offloads it to an asynchronous another thread. So you're not blocking on your I/O. So we're able to do all these crazy file operations that take a large amount of time, and just offload them. So we're seeing no slowdown, even though there's a lot of synchronous stuff going on. On our back end, again, through Rails, we have a MySQL database. It just holds all that metadata that Matt was talking about before, and a file store. We rename all our files so that we're not having collisions. MD5 is not the best. We're probably going to move to SHA-256 or something, but the gist is there. A binary is a binary. It doesn't matter what it's called. It's one file. So the service bus here is really the unsung hero. We're kind of playing middleman for the service bus, but one of our colleagues told us about that, and we looked at enterprise service buses, which are just ridiculous. They're bloated and hard to use, but we found a really lightweight one, which we'll talk about in a minute. And all it is it's just like a hardware bus. You stick a message on one end and something's at the other end, and it pulls it off whenever it feels like it. So it makes message passing so much easier. You're not writing your own RPC interconnects. You're just throwing something on a bus. It allows us to decouple everything. So now we don't have to worry about specific APIs for everybody, and we update one little thing. Now everybody else has to recode their tool. As long as they can work with the bus, you can plug and play everything else. Tying it all together, again, like Matt said, it's just a simple wrapper script for our consumer. So you can take that script and repurpose it. Half the things we're running are literally that exact same thing that Matt had, and just has backtick this command line batch file, and then it's returning results from that. So anything you have, doesn't matter what language it's written in, can work with these tools. And the same thing you can do. So that can be your own tool, or it can be a proprietary solution that expects a more manual intervention. You can wrap this around it and use those tools better. So and also you can just take it right from the get-go, and you're developing a solution. You start with this script and kind of build everything around it. So AMQP, again, awesome protocol. We hadn't heard about it before we started this, but it's an advanced message queuing protocol. So it was actually developed by financial companies to help with common business messaging, whatever that means. They wanted to pass messages between businesses. But Bank of America, Barclays, Goldman Sachs, JP Morgan, big financial companies who do a lot of transactions at the same time with all these different crazy routing rules, wanted to develop this protocol so they could all talk to each other, kind of the same thing we're doing, without having to reprogram everything every time somebody wanted to make a little change. And then the protocol was developed by Cisco, Microsoft, Novell, VMware, some pretty heavy hitters in the technical field. So it had some good ideas behind it and some good brains behind it. It's kind of an up-and-coming protocol. They're just coming to their 1.0 spec right now. But so anything you can think of that you're doing messaging with has been done in AMQP. Like web servers, email servers, they're all can have written ones that work with this bus model. So we talked before about the heavyweight ESBs. RabbitMQ is one we went with. There's other ones. Apache has ActiveMQ. There's a ZeroMQ. RabbitMQ is dead simple. There's Windows package. You just double click to install, and it's running as a service. Same thing with Unix. It just works, and then you can just start connecting to the ports and everything. There are libraries for every major language, and even useless languages like .NET or Haskell or whatever. So whatever you want to develop in, you have a library that you can just integrate right into your source code, and then you're grabbing stuff right off the queue. RabbitMQ is just up and running right from the get-go. But then again, it also has very powerful features, like you can set up access controls and vhosts, and load balancing just works. You just tell it, hey, you're in a cluster now. Here's the other IP. Boom, done. So the whole part behind it is you have these concepts of exchanges and queues. Now, a queue is exactly what it sounds like. It's a queue of messages that each subscriber declares. So you have your AV queue over here and your content detonation queue over here, and they connect to what's called exchanges. Now, there's a fan-out exchange, which is your shotgun approach. So every service gets every message, the queues fill up, and then your consumer has to decide, hey, do I really care about this file? So if you have a scanner that's targeted at PDFs, you don't care about executables. So the next one is called a topic exchange, where we actually filter based on the MIME type, the content type that gets declared. So this reduces the load considerably on your consumers. So you have a consumer that wants image/star, so it's not going to get application/PDF, and vice versa. So you can really offload, and you can only get the files that you care about for your specific scanner that you've developed. And they're very small messages. We'll show you a PCAP in a second, and they're tiny. So we kept them as small as possible with just some metadata in there. The one caveat is that we didn't put the files in the messages to keep them lightweight. We didn't want multi-meg things sitting in our queue and multiple copies of them. So we actually just provide a URL. So if your consumer actually wants the file, you can get it. A lot of AV engines can just work on a hash and say, do I know that hash? Yes or no. They don't care about the file. So we want to make it as quick for everybody as we could, and also provide the flexibility for people that wanted files. So here's a little PCAP right here, and just to show you, let's see if I get this projector thing working. Here is the actual payload of the message. So it just has a URL for them to get the file from, the MD5, and the content type. That's all you need for a scanner to work. They just have to know where to get it and what it is. And likewise, when they provide a result back, they're just saying the test is their name, so ClamAV. MD5 of the file they scan, so we can stick it in the database in the right place. A result is just a probabilistic result. So one is it's definitely malicious, and then you can go anywhere in between there. And then finally the version. So you can have the versions of your signatures. If you have a version 1 of a tool and then you're scanning with your version 2, you can see what you actually scanned with what. So you can just keep modifying this. And we put this all on the consumers, so the actual Intersect tool doesn't have to know anything specifically about any of the consumers working with it. They're kind of all declaring everything about themselves. And because we love Visio so much, here's a actual workflow diagram. I feel like a manager now. So here's Intersect itself. Files go into it. The transfers exchanges over here. We have all the queues, so the files go into their appropriate queues depending on their file type, or they can just grab all of them if they want to. And everything is asynchronous here. So as this queue might be full, this tool might be working one file every 2 minutes, and this one down here might be a quick AV engine that's scanning everything once a second, and that's fine. They're all sticking everything back on the exchange over here. Their results, and Intersect is pulling those in, so it's very fast, and anything can go up and down at the same time. Whenever it wants to, it's not going to impact each other. So I mentioned the RabbitMQ load balancing. Dead simple, you just turn it on. The consumers actually load balance. We found this out by accident. So you can have multiple instances bound to the same queue, and it will alternate which files get where. We actually had 2 Python scripts running at once, and we're like, why are we getting every other file? And then we realized we had one old version running. But the nice thing is you can just throw more hardware at it, or stand up new instances of your script and load balance it there. So we think some advantages to this approach are, it's a single pane of glass. So we can consolidate the results from different disparate services. So you have your results from this tool, your results from this tool, and one tool says, well, this one I think is like 20% certain that it's malicious, and this one says, well, I'm like 30% sure it's malicious, and then your AV scanner says, well, that's fine, I don't care. So now you're kind of pulling all this together, and then you can set your thresholds, and your analysts can say, I'm going to get an email if any tools kind of agree that it's more than 50% malicious. So you're doing all the triage for them. And then your analysts can look through results or transfers by any of that metadata. So now you say, hey, this email address was sending us some bad files, or hey, this IP address was serving us some bad files. Let's look at other stuff that's come from them, or anything else that you can pull out. If you're doing file fingerprinting and you're looking for certain metadata that you're able to pull out of executables, you can now search on that once you get a hit. Hey, you think this file's malicious now? 6 months ago, that same signature appeared in a file that you had no clue of. Are they both malicious, or maybe now it's malicious and the old one wasn't? And finally, like Matt said before, you can evaluate the efficacy of different services. So you can stand up, not playing vendor wars here or anything, but you can stand up like a Symantec AV and a McAfee AV right next to each other, feed in a whole bunch of files. Which ones hit on which, but which one works better for you? I'm not saying one's better or one's worse, but maybe your environment, one is better. The files that you're seeing, one will pick up better than the other one. Who knows? But this will allow you to actually play them both next to each other without having to actually tie them into your infrastructure. So it's agile. We can add new consumers trivially. So we have a really good research program in the lab that we work in. So somebody comes up with an idea, hey, I want to write this tool that looks at blah file type for this, very little detection thing. So instead of having to go through the whole red tape and jump through hoops to go to corporate and say, hey, can we get all the PDFs coming off the wire? Yeah, right, like that's going to happen. So what we took care of that for them, and now inside that lab, they can just come to us and say, hey, we want all the PDFs. We give them the 7-line Ruby script. They just tie it in, and bam, they're getting everything right there. So they don't have to deal with getting files and parsing files and all that stuff. We're doing all that for them. And when they update their consumers, their scanners, so you got a version 1, 6 months later you got a version 2, now you want to go back and rescan all the files. Well, you have a corpus of a lot of files, and you can see what are the differences between my version 1 and my version 2. Am I detecting new stuff from these old files? And again, if anybody's worked on a research project, it's only so good if you're working with some sort of, pile of test data that you've developed yourself. Of course, stuff's going to trigger if you developed it yourself. But if you can get thousands of files right from the get-go, how good can your thing be? And and then you can start things like load balancing, load testing, and more advanced testing that's usually harder to do on your own tools. We mentioned this a couple times, it's asynchronous. So you have your consumers that are bound to these queues. Now the cool thing about the queues is they'll keep filling up even if you're not connected. So you have your AV engine, or more than likely you have your homegrown research engine that somebody submits a bad result or something and it crashes. So now that queue is filling up with more files. You fix your tool, you start it back up, and then you're catching up with your backlog. So you're not taking down your infrastructure. You're not putting this very fragile piece of software in line in your on your network that nobody in corporate is going to approve. So you're able to do this research and develop it, and then maybe if it gets to the point where it is enterprise ready, then you can take that step. But at least you can test it on a real amount of data and real types of data before getting it out there. And the other thing is, they won't take services won't take each other down. Each developer, each person works with their own box, their own VM, whatever they're developing in. They don't need to be, the same box as anybody else. As long as they can talk to that bus, they can work with it. So the last thing is, you can leverage resources better. So, you have a COTS tool, something like a content detonation tool. Maybe it takes 2 or 3 minutes to test a file, and you need an analyst to drop a file in a certain folder, wait for the results, look at it, pull a PDF of results or whatever off this box. So that thing is maybe lightly utilized between 8 and 5 p.m. and then that's it. At night, that box is cold. So, and you're paying a lot of money for boxes like that. So if you can automate that, where you can have these things, as soon as the box is ready for another file, it's getting another file constantly, 24 hours a day, 7 days a week. That thing doesn't need a break, right? So have your files constantly be utilizing that, and you're actually going to get your money's worth out of it. And you're going to be able to feed more files into it than a normal analyst would be able to. And if you have a queue that's slowly getting bigger and bigger, and you realize, hey, I'm never going to catch up with this. I'm getting more files than I can consume. It's a simple buffer problem. Just throw more hardware at it. Buy another box, set it up, bam, load balance, and you're getting files in half the time. It's not one file every 5 minutes. It's 2 files every 5 minutes. Or if it's a homegrown thing, just set up another Linux server, throw your Python script on there, set up, and you're good to go, and you're consuming more files faster. So you can utilize what you have or whatever you want to pay for. You're able to utilize it to the best of its ability. All right, I'm going to throw it back to Matt here.
So we're going to revisit the needs that we came up with, gather intelligence, protect, and measure efficacy, and see how we did. We think that we can now gather intelligence better with all of the metadata coming in and the results from each disparate scanner consolidated into one place. And it allows us to act on it and analyze it much faster. To protect, just an example of how we're using Intersect right now. The producers we have, we're getting files coming in off of the web proxy, so every time someone downloads a certain subset of files, we're getting them from network taps and also email attachments. And we do have quite a few scanners set up as consumers to consume all these files and deliver results. Our workflow is the file comes in off the network. Usually someone was downloading it through the proxy or was emailed. The scanners do the triage, and if it is suspicious, an analyst is alerted via email. And we're also beginning to accumulate data on the files as the scanner results are coming in. And we can now start to retroactively scan files when new tips and signatures come out to see if we've seen it before. So it's a lot faster to go ahead and do that than to wait till you see it beaconing on your network or something like that to find an infection. And we can start to tie different files to the same attacker if we have that information. Some statistics on how it's been performing. We turned it on around December 14th, and there were a few hiccups in the first couple days, but after that it's been pretty solid, and we've scanned 175,000 unique files so far. We're averaging about 4,500 unique files per workday. That's weekends taken out because it's obviously a lot less. And our max was 7,800 in a single day, and our scanners have not been seeing much of a backlog. And we have tested taking a scanner down, or once in a while they will just fail. You come in the next morning, you see the queue's backed up, restart it, and it just chunks right along. Everything was saved in the queue, and it can pick up right where it left off. Our need to measure efficacy, we're now getting all that data in one place, so we can compare the COTS tools to our research projects. And again, we can see how our research projects are progressing. Every time one updates to a newer version, we could conceivably go back and scan the same exact files that it scanned the first time to see if it found anything else in those old files and make sure it came up with at least the same results for maliciousness. We have been thinking about other possible use cases for this type of architecture, and we were thinking about egress filtering in sort of a DLP type solution where a scanner could be written looking for social security numbers or credit card number type patterns or anything that in your organization you would consider a dirty word to be pushing out to the outside. And then you could be monitoring your outbound email attachments or something like that as they're leaving your organization. Or possibly make it a file transfer solution. So if a user needs to bring a file into your organization or remove it from the organization, it could be put into a file share, and then the file share could have a script running on it that would then suck it up, submit it to Intersect, and the file would then be scanned. In this case, you may not want users to be downloading files directly to the internal network from the internet. It would go through this first. And back to Photios for some future improvements.
All right. So one thing, kind of our mantra from the get-go is don't reinvent the wheel. So we think we should eat our own dog food and not reinvent the wheel for a lot of our analytics. So we're trying to work on utilizing Splunk or some other SIM tool that provides a better UI, alerting, searching, things like that. Again, because we can decouple everything, we don't really need our analyst's view to actually be residing on the same box as the queue server or anything like that. So we're hoping to be able to pull all these results in and do some really cool analytics. Because if any of you use Splunk, it does a lot of the key value pair stuff and correlation that you couldn't even dream of coding yourself. It does some good stuff. File type checking, it's a kind of a bane of anybody that's worked on file streams and trying to figure out what it is. It's hard. You can do it pretty well for a lot of file types. It's hard to get perfect. A little dumb example down here is, if you just run it on a bunch of doc types. Well, the old doc types come up as MS Word because they were. The new ones are actually zips. If you ever try to unzip a PPTX file, every slide is a different XML file, and every image is its own image file and things like that. So this is good and bad. One, it breaks a lot of scanners that were just expecting one flat file of a presentation. On the other hand, you can actually literally in-depth analyze every part of it. So it's good and bad. And there are other tools that can analyze these file types better and give you a good sense of if you see something that just says this is an application.zip, you don't really have that contextual information to know, is it really a document zip or is it really actually a zip file? So maybe there are some tools that could do that better for us. And Matt mentioned before archive explosion. Simplest form of it is you are able to unzip a zip file, resubmit every single file back in, and then the threat of that zip file is really just an aggregate of the threat of all the files inside it. And because this is an automated process, this could recursively happen forever. However many zip files, maybe that's a common technique is they just hope, hey, I'm not going to look too many layers inside of a zip, so maybe I can evade AV that way. Well, this will hopefully be able to get through the entire zip file forever. I mentioned the 2007 file format is actually a zip. But the other interesting use case we came up with was disk images. Maybe you have a forensic tool that can take a DD image of a disk, extract every file stream out of that, and resubmit it. And now you have certain scanners that want certain file types, and now you've just created a forensic application out of this framework. So with that, that concludes our presentation. I know we kind of flew through here. Any questions? Yes.
You mentioned that you don't have much of a backlog with the samples that you're working with now.
Yep.
If you were to scale this up and you wanted to maybe not scan everything, but just the things that were probably most important, can you consider it a scoring system?
So the question was dealing with the backlog, if we've considered some sort of scoring system for the files. So the problem with that is that Intersect itself doesn't really touch the file, so there'd be no way to score it from the get-go, but maybe you could have some scanners that can get the file and scan it first and then maybe do a triage for the triage. So it could be possible, but the reason we're not seeing a backlog now is because we are filtering out on content type, and every scanner wants such a specific content type that even though we're seeing 7,800 files or 4,500 files a day, there's only a couple hundred files per file type. You know, we have X number of PDFs and X number of docs and X number of images or executables or whatever. So each of them is able to keep up. And it's actually more beneficial instead of trying to have a better filtering system in the front end, just throw more hardware at it, you know, or just set up another Python script or Perl script or whatever. Answer your question? Sweet. All the way in the back. Okay. So the question was, how do we interact with COTS products? But when you say post back, you mean like reporting to them or something like that, or? Mm-hmm. Gotcha. So yeah, so the question is how we interact with some COTS products. A lot of them, you know, do have command line tools. So you know, I think Symantec does and McAfee does, where you can actually call it on a Unix box. But you know, that could be something that you could write. So if you have something that expects a file to be on your desktop and then calling something, there are a lot of user automation type tools where you could literally have your tool drop it in a certain folder and have that folder be watched by your manual AV process, and then take your report and parse it and post it back up. You know, we have some other tools that expect a pretty manual workflow that we've been able to do in a way like that. So the gist is, if you can think of a way to do it, some of them, yeah, I'm sure there are some tools that just won't work, right? You got to like manually drop it on this application and there's no way to do it. But if a lot of things have any sort of automated way to do it, you'd be able to interface it with it. All right. Question?
Yeah, so since you have like this large amount of MP5s,
Mhm.
have you ever thought about interfacing with websites to do checking? Say like if like a threat expert or a Ubis or JSON hack or something like that knows it's bad already, just do it there instead of having some sort of scanner or something like that.
Right. So the question was, have we thought of interacting with any of the publicly available repositories of MD5s that have already done that, like a VirusTotal or Anubis or things like that? And we actually wrote a VirusTotal wrapper that took our hash, uploaded it to VirusTotal, took the results back from VirusTotal, and put them into Intersect. So there are a lot of them, but some of them are good, but some of them are very limited. You know, they only run certain scans on it, and so that could be a great first blush. You know, it's like a no biased, so it'll know, yes, if it hits, it's malicious. If it doesn't hit, it doesn't mean it's not malicious. So we can use that as a first indicator, but you still want to do a lot of your internal stuff, because these targeted one-off attacks, you know, if somebody's writing something for you, it probably hasn't been submitted to any of those other services anyway. But for a lot of the low-hanging fruit, yeah, those would pick it off right away, and that could just be another service for yourself. Question? Oh, wow, a lot of questions. You gotta speak up, sorry, I can't hear you. Right now, we store like source IP, dest IP for people downloading files, or if it were off of emails, it might be from address and to address. But the interesting thing is, again, our mantra is it's whatever you want it to be. So if you're in a web proxy type thing, you might want to pull all like the user agent string and all those sort of path that it was downloaded from. Actually, one important thing that we track is the original file name. So if something was mislabeled as a .doc, but it was really a .exe, that might be a little bit of an indicator to you. But maybe there are files coming in as multiple different names and they're targeted towards certain people, but it's really the same file. So that could be something useful to you. But it's really whatever will help your analysts in triage at some point, because the point is that when they get a hit that, hey, this file might be malicious, they're looking through that metadata to try to recreate what happened. So if you have source and dest IPs, they might be able to look at your net flows or your packet logs or your proxy logs or any of that sort of stuff to figure out what really happened and where that person has gone or what's happened with an infection or things like that. Yep.
We're also storing, say, if it's an antivirus and it hits on a signature, the signature name, or what we're calling a threat score, as you could sort of see in the packet capture. So we have our services calculate, and it's up to them how they do it. If it's an AV, it's probably just a binary 0-1. But how malicious on a scale of 0 to 1 do you think this is? It calculates that, and it returns us that as well. Or anything else that the service wants to return. So we have a free-form field where it can return anything it wants. We'll go ahead and store that, and that can be searched on later as well.
Your message bus architecture seems really well suited for choke points that are central aggregation points for proxy and whatnot.
Yep.
Have you worked at all at tying in also things like desktop APs running to detect when somebody plugs an infected USB or CE in? I mean, it happens locally. You don't even see it until the results come in.
Right. I mean, so yeah, I mean that could easily be done. You could literally just have 1,000 producers as opposed to one central producer. So if you want to write something that we had written one that watches inodes on a Unix machine. So whenever anybody drops a file in like a temp directory, and it was meant for
Yes.
yeah, I noticed. So it says, hey, this file was just, we finished writing it. Now let's test it. So anything, and there's equivalents on Windows too. So you can be watching a Samba share. So one of the use cases Matt said, so say you want to literally cut your users off on the internet, and somebody wants to email a file out or put it in some sort of Dropbox that's available to the public. They have to drop it in a folder first, and that will automatically get scanned by this. And then kind of once it's good, it passes through the other side, which somebody can grab it from. So.
The other thing you'll have a problem on is who says what is good, at what tolerance level is good. Everyone has their own opinion on what a clean file is.
Yeah, and because you have all the, we'll get to in a second. So because you have all the metadata, something that you might trust a certain scanner or some certain tool more than others. So it's up to you what you want, how you want to weight things, and what you want to do with it. So if you are bringing a file into your absolute core, crown jewel infrastructure, you may only want to do it if it's absolutely clean according to every scanner. If you are, kind of working more on your DMZ, you maybe just want to care if it passes antivirus, and you don't really care what these developers say of their own research tools. So it's really whatever you want to do with it. There's a question over here.
Yeah, you mentioned target threats, persistent threats, but you've got the commercial tools.
Mm-hmm.